this video we will go over how to determine the group the element is in given electron configuration. So the way we have to attack this problem is by noticing where the electrons march in the periodic table. So they march in a specific order. So for example, hydrogen has only one electron, so it's going to go in the 1s orbital. All these different orbitals, s, p, and d, have different shapes and geometries and orientations. They also have different slots. So if you remember, the s orbital has only one slot, so that's very easy. And it will go spin up and spin down. The p orbital has 3 slots, and it's shaped like a dumbbell. And the d orbital has 5 slots, which have a little bit more of a complicated geometry and orientation. But the electrons are going to march in a very specific order. So 1s1, the second electron, or the 2 electrons of helium, we're going to go and fill the 1s spot, so that's going to be 1s2, and so on and so forth. As long as you know the order in which the electrons go in, and realize they're going to go in, at least for the p and d orbitals, not the s. For the p and d orbitals, they're going to go spin up, spin up, spin up. Before they pair, spin down, spin down, spin down. If you know that principle, that's called the Pauli exclusion principle. If you know how they go in, as well as the order they go in to the orbitals, then you can be able to solve this problem. So the first problem asks us to determine the group. So if you remember, the group in the periodic table is the column in which the element resides. So neon 3s1. So neon is going to be right here. It has 10 electrons. So the 10 electrons are going to go fill up their slots, and then we go to the 3s orbital, the 11 electrons in sodium. That 11th electron is going to be going into the 3s1 area. So this actually, neon 3s1, represents the electron configuration for sodium. And we know sodium is in group 1 of the periodic table, or 1a, and those are called the alkali metals. So the answer for part A here is sodium, and that is an alkali metal. Part B, it's asking for neon 3s2 3p3. So that's also pretty simple, because after 3s, it's going to go to 3p. And so 3p1, 3p2, 3p3, we're talking about the element phosphorus. Okay, so phosphorus with its 15 electrons, 10 of them are going to go to neon, fill up the slots that were formerly for neon, and then 3s2, and then 3s1, 3s2, 3p1, 3p2, 3p3, as stated before. So phosphorus is actually in group 5a of the periodic table. That's this version. So other periodic tables will actually number it just straight numerically. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So neon 3s2, 3p3 would be group 15 or group 5a. Part C is asking for neon 3s2, 3p6. So if you remember, neon has 10 electrons. And then the 2 electrons for filling up the 3s orbital, plus the 6 electrons filling up the 3p orbital. Those 6 plus 2 electrons is 8. 8 plus the 10 electrons in neon give you 18. This is actually the electron configuration for the noble gas argon, which goes in group 8a or group 18, and this is more formally known as, or called, or referred to as, the noble gases. Finally, we have D. We have the electrons of argon, which is 18 electrons. And then we're going to fill up the 4s2 and then go to the D block, the transition metal block, and fill up 8 electrons in the 3d orbital. So we have argon. So the key to solving all of these electron configuration problems is knowing the order. So after 3p, the 18 electrons fill up like the electron configuration of argon. Then we're going to go to 4s2 and then 3d8, 3d1, 3d2, 3d3, 3d4, 3d5, 3d6, 3d7, 3d8. So this is nickel, and on the periodic table this is group 8b, in this version of the periodic table. Other versions will have it as group 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, group 10. So this is the electron configuration for nickel, group 8b if you're using this periodic table, or 10 if you're using other versions of the periodic table. So this is the D block, this is the transition metal block, and the groups, again, it depends on what periodic table you're using. My version, they call it 8b. Other versions, numbering it straight up, 1, 2, 3, 4, we'll call it group 10. Argon 4s2 3d8. So the group is the main column in the periodic table, and some of them have very specific names, like the alkaline metals, alkaline earth metals. These are the halogens, and these are the noble gases. Others don't have a very specific name, so we just go by the number based on what version of the periodic table we're using.